Question 3 here. So we have a particle moving in the xy plane. So they give us the velocity. That's important. So they give us the velocity. It's a vector value function, 4t and sine t. And they tell me the position at time equals 0. And that is 1, 3. And they want me to find the position at time equals pi. So what I'm going to need to do, we should know that the position is equal to the integral of velocity. So what we're going to have to do is integrate this, use the 1 to solve for the c, and then integrate this one and use the 3 to solve for the c for that one. So we'll go ahead and do that, and then I'm going to plug in t equals pi at the end. So I'm going to break these down into the x work and the y work. So x, velocity, I'll write Vx is equal to 4t. So x position at time is the integral of 4t, t dt, which is going to be t squared. I'm going to take the 4 and divide it by the new exponent, so I get a 2. So I get 2t squared plus cx, I'll call it, because it's the c for the x component. And then I'm going to use my 1 as my t value, or my 1 as my x value, and 0 as my t value. So I'll write that. We know x of 0 is equal to 1. So that gives me 1 is equal to 2 times 0 squared plus cx. And you should easily see that cx here is going to be 1. So I'm going to combine this line and this c value to get x of t is equal to 2t squared plus 1. And then I can I can answer part of the question. It says, what's the particle's position at time equals pi? So I can figure out the x position by plugging pi in for t right there. So let's go ahead and do that. X of pi is equal to 2 times pi squared plus 1. If I had a calculator, I could do a decimal, but I think this one is one that we're not doing with the calculator, so I'm just going to leave it like that. Now, we're going to go ahead and do the same thing for the y's. Y. Vy is equal to sine t. Y of t is equal to the integral of sine t dt, which is going to give me a cosine of t. But think about it. Cosine derives a negative sign. This is a positive sign, so I need to have a negative. And then I'm going to say plus c sub y. So now I'm going to use my initial conditions. If you look t equals 0, I get a position of 3. So what I can say is that y of 0 is equal to 3. So that gives me 3 equals negative cosine of 0 plus c sub y. You should know that cosine of 0 is 1. So I get 3 equals negative 1 plus c sub y, which I can then go and say c sub y is equal to 4. From there, I need to find the position. I'm going to write the position function out for the y's. So I know that y of t is equal to cosine of t. I'm taking that from right here. And then I'm going to take plus c sub y. Well, c sub y is 4. So cosine t plus 4. Now I'm looking for y of pi, just like I did over in the x's right here. And that is equal to cosine of pi plus 4, which, negative. I dropped a negative. You know, that happens to the best of us. Negative. Point. Remember that negative right here? I need to carry that here and here. So, negative cosine, you should know your unit circle. Pi's over here. Cosine is the x-coordinate. So cosine of pi is equal to -1. So we get a -1 plus 4, which gives me 1 plus 4, which is 5. So the answer for the position is going to be to pack this and this into a vector. So what's the position? It is 2 pi squared plus 1, comma 5. And that is your answer.